Hello everyone, and welcome back to Reverse Engineering Linux 32-bit Applications. In this video, we're going to continue our discussion of stack buffer overflows. In particular, we're going to talk about stack protectors. So in a previous video, we compiled a simple application. We stepped through it with Evan's debugger. And we noticed that, yes, in fact, it does crash, but it doesn't seem to crash in the way that we had expected. It seems as though it would try to crash in a slightly different manner. So what's going on there? Well, by default, GCC will enable a stack buffer protection. So it will automatically add code in order to prevent you from having a stack buffer overflow that is going to cause trouble. So we need to disable that. Again, another great reason to use Linux. By the way, even if you're using Windows, you could use the GCC compiler, and that would also offer you this protection. It's just on by default in Linux. So here's what we're going to do. We're going to recompile our application. So I'm going to use GCC. And here's my command from before. And I'm just going to add to this. I'm going to give it -f no stack protector. And now I'm going to rerun my application in EDB. As before, I don't really care about the output because there isn't any. And I'll go ahead and run to my breakpoint. I will run my analysis. And let me go ahead and set another breakpoint right here at my call to stir copy. And I will run to that breakpoint. So I'm ready to call stir copy. Once again, using the cdecal calling convention, I have pushed onto the stack the two parameters that stir copy wants. The first parameter is the destination. Second parameter is the source. Recall that we push things from right to left onto the stack. So here we have the source, which is a pointer to the location of all these A's. And here's my destination, which is, of course, right here on the stack. Why is it on the stack? Because this is a local variable. So notice down here at FF, F5, C5, FC, I have returned to this location, which is buffer overflow main plus 50. This is the location I'm supposed to be returning to. And if I overwrite this, it's going to try to go to a different location. So let's go ahead and just step over this stir copy. And sure enough, in this case, that location has been overwritten. So let me go ahead and finish this function. I'm going to add hex 10 or 16 to ESP. So I made some space on ESP. And now what? Actually, when I add to ESP, I'm taking away from the stack because the stack grows toward lower memory. Now I'm going to move 1, that's my return value, to EAX. I'm going to call leave. Leave will clean up my stack. So notice what happens here. When I step over leave, and it's getting ready to call return. So return is going to attempt to return to this address, 41414141. And I think it's going to have some troubles. So let's go ahead and step. And sure enough, it says the debugged application encountered a segmentation fault. The address 41414141 does not appear to be mapped. So here, my application has crashed. So now that I've eliminated the stack protector, I can go ahead and exploit this application. Again, by default, I couldn't do that with Linux because the Linux compiler, GCC, has built-in protection against such things. But I foolishly disabled it, and that has allowed this to happen. All right, so I've been able to crash it and crash it kind of in the way that I want, but I'm not quite there yet. I still have some issues. I still have to redirect this to some shellcode. So how do I do that? Well, that actually will be the subject of a future video. So in this video, what did we learn? We learned about how we can turn off the stack protector and how that will allow us to actually exploit an application that has this protection turned off. In future videos, we will learn how to redirect to exactly where we want it to be and how to inject some shellcode. But that is all for this video. Now, as a reminder, this video is one in a series of videos that we have here at Pentester Academy on all kinds of information security topics. And I look forward to seeing you soon in this course or another fine course here at Pentester Academy. See you then.